Welcome all. Max here and
And Ben? Ben here.
and Ben. So I'm here in Berkeley. Where are you at, Ben?
In San Francisco, Soma.
Brad. For people who haven't been on the live stream before, we have a running YouTube playlist that you guys can check out at the Accidental Engineers YouTube channel. And this video will be added to that. So if you guys can't watch the whole thing right now, you can watch it on YouTube later. But where do we leave off last time? For people who haven't been on the podcast before, we're doing MIT's Distributed Systems course, which is all in Golang, the Go programming language out of Google. But we were working on Lab 1. Let me drop a link to the schedule of the course and our public GitHub repo where we're working on this in the group chat. We can add it on the YouTube URLs details. Oops. So where we left off was that we were looking at the lecture, and I'll go to screen share here. Lab 1 is due after 2 weeks of the course. We're about halfway through the lab. This is the lab about MapReduce. Well, I can't really make the font bigger. But we'd read through the lectures 1 and 2 about distributed systems and just generally, and then RPC and threads. Those lecture notes were pretty jank. I don't know if you felt the same way, Ben.
Yeah, they were pretty light. The first one about MapReduce was good.
Yeah. It looks like the third lecture is about Google file system. And they wanted us to read the academic paper about Google file system from 2003 before attending this lecture or whatever. I didn't do that.
I didn't do that either. We're gonna have to guess as we go.
Yeah. There was a couple of helpful links about Go, the programming language, that I did check out. One was their guide to idiomatic Go, which was on their official website called Effective Go.
Okay.
It wasn't crazy educational. Like, it's kind of information dense, and honestly, I don't know if it's very well written.
Yeah.
Like they give basic language rules, like how to write single and multi-line comments and shit, but outside of that,
Yeah. I personally think the best way to learn a language is just to jump into source code and like try and make something work, which is kind of what we're doing.
Agreed. So for audience members that don't know me and Ben very well, neither me and Ben have, I don't think, ever for work written a line of Go programming language. Is that right?
That's correct. I've played with Go off and on since its release, but not like any serious capacity. This is definitely the most serious Go code I've worked on.
Well, we've made a ton of headway. Let me check out where we've got our code base for the labs. The labs are organized in the source tree, and the first lab is this MapReduce lab. So a lot of these are garbage input files, but all of these Go files were provided to us, and then we had to fill in the code so far. So, for example, we had to write the implementation of MapReduce, and we've written it in a way that isn't amenable to distributed computing at this point. So that was the first part of lab 1. And we can start working on lab 2. Ben, would you rather read these first lecture notes? There's 2 more lecture notes before the first lab was due. I don't think they're a prerequisite to continuing for us to work on the lab, you know?
It's up to you. I'm down for either. I personally would rather just code.
I agree. Let's just do that. This is the link to the lab. I'll drop that in the chat too real quick. We got Go installed. There's some preamble about how the source code is organized for the labs. There's some guidance about part 1, which is running these sequential tests, which are not concurrent or parallel or distributed in any way. We got those tests to pass. Writing a map and reduce function for running a word count was, I think we did that in like 15, 20 minutes.
Yeah, I think we got that working.
They gave us a ton of hints. It was very, very reasonable. We tested the solution, and you guys can check out how we did the first couple labs in our pull requests on the Git repo. And part 3 was where we left off, which was distributing MapReduce tasks. Shall I just read it out loud? Or?
Sure.
So our current implementation runs the map and reduce tasks one at a time. One of MapReduce's biggest selling points is that it can automatically parallelize ordinary sequential code without any extra work by the developer. In this part of the lab, you will complete a version of MapReduce that splits the work over a set of worker threads that run in parallel on multiple cores. While not distributed across multiple machines, as in real MapReduce deployments, your implementation will use RPC to simulate distributed computation. The code in MapReduce master.go does most of the work of managing a MapReduce job. We also supply you with the complete code for a worker thread in MapReduce worker.go, as well as some code to deal with RPC in the common RPC file. Your job is to implement schedule in MapReduce schedule.go. The master process calls schedule twice during the MapReduce job, once for the map phase and once for the reduce phase. Schedule's job is to hand out tasks to the available workers. There will usually be more tasks than worker threads, so schedule must give each worker a sequence of tasks one at a time. Okay. Schedule should wait. Come in.
Sorry, keep going.
That doesn't sound right. It sounds like the master should hand out individual tasks one at a time. Is that what you're thinking?
I'm not sure. So schedule must give each worker a sequence of tasks one at a time.
And it should wait until all tasks have completed and then return. I mean, that part makes sense, but yeah. We'll take a look, because what we found when we were reading the lab instructions is we would then go and look at the source, and it would be like a bunch of comments that explain exactly what we're supposed to do.
Things make more sense then.
Schedule starts and waits for all tasks in the given phase, whether a map or reduce. The map files argument holds the names of the files that are the inputs to the map phase, one per map task. And reduce is the number of reduced tasks. The register chan argument yields a stream of registered workers. Each item is the worker's RPC address, suitable for passing a call. Register chan will yield all existing registered workers, if any, and new ones as they register. So I'm guessing our schedule function will just do a while loop.
Yeah.
While there are still pending map files that haven't been processed.
Yeah.
Or pending intermediate reduce files. So it'll do 2 while loops, one for the map phase, one for the reduce phase. Or I guess the schedule gets invoked for each phase. So it'll just be a while loop that pulls register chan to get addresses of workers who don't have work assigned to them. Is that right?
Yeah, I think that makes sense.
Okay.
It tells workers to execute a task by sending a worker.doTask RPC to the worker. This RPC's arguments are defined by doTask args in common RPC. The file element is only used by map tasks and is the name of the file to read. Schedule can find file names in map files.
Okay. Makes sense.
Yep.
Use the call function in common RPC to send an RPC to a worker. The first argument is the worker's address as read from register chan. The second argument should be worker.doTask, which is probably a struct of some kind.
Yep.
The third argument should be the doTask's args. Oh. I think worker.doTask is straight up a string, which is the name of the RPC that the worker process should perform.
I think that makes sense.
args is an args, or the set of arguments to that function, or RPC. Okay, so solution to part 3 should only involve modifications to schedule.go. Okay, so we're just going to be sitting in schedule.go. If you modify other files as part of debugging, please restore their original contents and then test before submitting. To test your solution, you should use the same Go test suite as you did in part 1, but replace -run sequential with -run test basic. So I'll do that real quick over here. Let me make sure my Go path is set. My Go path is not set. I think it's set to be, we're supposed to set it to the source dir. Is that right?
Number.
We are in the MapReduce directory. Maybe we got to go up one. Oh, it must be absolute. Oh, that's annoying.
It should be set to the project directory.
You said the project directory?
Yeah, that directory, I think. Yeah.
Okay. Try running tests. Can't load package. Oh, we got to go up one more. No Go files.
Yeah,
maybe it is supposed to be source.
Yeah, and then you have to cd into the MapReduce directory.
Cool. Okay, so we're getting the failing test now.
Okay.
Just for our audience to see what Go path looks like. It's the path to the source directory of our repo, and then the shell is currently in the MapReduce directory, which is where, well, we have all these text files, but we also have all our Go source files for the MapReduce lab.
Yep.
So we did Go test, -run, test basic. So if we go take a look at this test real quick, test basic, that's just one test. It calls a setup function, creates 2 run worker instances. I think that, to be honest, from all that I've read about Go, I've not seen any mention of object-oriented programming at all. Like, I don't know if that's me hallucinating, but this looks like it's instantiating instantiating a class as an instance of an object. And then this Go keyword is a Go-specific tool for shelling out to another thread. I mean, not shelling, but invoking a new thread.
Yeah, putting it asynchronous thread or
so
routine.
We can take a look at run worker, but we probably don't. The important stuff is that the test is probably invoking whatever we're doing in the schedule.go file, which they're telling us is the only file that we need to touch for this part of the lab.
Yep.
So we were able to run the tests and get the failing tests. Oh, it got a lot further this time. I wonder why. Maybe I missed that output. Did you see this stuff?
Oh, yeah, I think we got that last time.
Okay. Method cleanup files has wrong number of inputs, I guess. Method lock has wrong number of ins. Okay. Wait, wrong number, starting MapReduce task test. So these look like the for loop we saw in the test. That's invoking run worker.
Okay.
We'll take a look at where these log statements are originating from. But it looks like here's the schedule. It's not, so we're supposed to do stuff between these 2 lines. We're supposed to do stuff between these 2 lines, and currently we do nothing. Looks like we get an error. There's some server registration going on. And then finally trying to open a file that doesn't exist. Okay.
All right.
Do you think there's more to read here in the lab, the part 3 lab instructions?
Yep, and these hints are going to be useful.
RPC package documents the Go RPC package. Schedule should send RPCs to the workers in parallel so that workers can work on tasks concurrently. Makes sense. You will find the Go statement useful for this purpose, like in the test. So we can click through on this stuff in a little bit. schedule must wait for a worker to finish before it can give it to another task.
Yep.
Or sorry, before it can give it another task. You may find ghost channels useful. Okay. Sync.wait group. Probably group is like grouping all of the pending file inputs to be worked on together and then waiting for all of them to complete or something like that.
Yep.
The easiest way to track down bugs is to insert print statements, collect the output of a file with redirecting output, and then think about whether the output matches your understanding of how your code should behave. All right, pretty common sense. Yep. To check if your code has race conditions, run goes race detector. Cool. Okay. Yeah, cool. We can try adding that argument dash race and see what happens. Doesn't say anything. I guess we don't have any race conditions yet.
Yeah, I guess it doesn't work. So.
Okay, let's take a look. I want to zoom ahead and see this last part because there's part 4 and part 5, and we're working on part 3. Okay. And part 5 is extra credit. This one looks like it's kind of similar to the word count one, where we're kind of, I think the idea is to demonstrate how what we've done in this lab is kind of similar to building a Google search engine.
Yeah, inverted index.
Yeah, that might be cool to work on, but it also might be time intensive. We'll see how far we get. But yeah, we should be able to, I'm hoping we can I'm optimistic we can do parts 3 and 4 today.
Yeah, hopefully.
Part 4, handling worker failures. In this part, you will make the master handle failed workers. MapReduce makes this relatively easy because workers don't have persistent state. If a worker fails, any RPCs that the master issued to that worker will fail. Thus, if the master's RPC to the worker fails, the master should reassign the task. That sounds reasonable. I think it's like learning a little bit on our parts about how to handle panics or exceptions basically how to handle RPC failures, because I don't think we'll need to handle exceptions. We just need to retry.
A flag that'll start throwing errors 10% of the time or something.
Yeah, I mean, we can straight up look at the test, because it looks like here's how we run the test. I'm curious. This is a diversion from part 3 of of what we're working on, but I don't really care. So the test 1 failure, I think maybe this number right here indicates failure. Yeah. That last argument to run worker. I don't know where run worker is defined. Any idea where it might be?
The run worker is defined.
Maybe in worker? Here we go. So it's the number of RPC. Where is NRPC used? So it's a property of worker. I don't know. I just believe that they're introducing failure somehow.
Yeah, for sure.
Let's take a look at part 4 again and how we're supposed to edit schedule.go. So we have whether this scheduling function is active or invoked for both the map and the reduce phases. That's a lot of to-do statements. All end tasks have to be scheduled on workers, and only once all of them have been completed successfully should the function return. Remember that workers may fail and that any given worker may finish multiple tasks. Okay. So the idea is that workers aren't to be delegated only one task and then taken out of the pool of candidate workers, but yeah. Yep. They may become available again after they're finished doing the work that they're doing. So it seems like end tasks is the same as the length of map files. Oh yeah, sorry. I was thinking that these were the arguments to the schedule function, but They're up here.
Yeah, so in tasks is the link of the map files and other.
Number of inputs for or outputs.
Yeah.
So, oh, okay.
Oh, and
so,
other is just the other. If you're in the map phase, then it's the reduce phase. If you're in the reduce phase, then it's the map phase.
Yeah, yeah. So, like we were mentioning earlier, this is probably just a big while loop. I don't think. Are you familiar with while syntax for Go?
I am not.
While you were sleeping, while going. So it looks like they don't have an equivalent of while; they just have for loop.
Okay.
So we can just have a for true or something like that. We just need to make sure we break out of it. I don't know if that's true or not, but let's give that a shot.
Okay.
Say again?
Sounds right.
Okay. Shall I give it a shot?
Sure.
Yep, looks good.
Huh?
So while we're in this for loop, at the end of the for loop, we'll check the number of remaining tasks. And if it's 0, then we'll want to break out of the for loop. Is that fair?
Yeah.
I'm
just looking up what like a channel is here.
Okay. So we've got this for loop, and we have this variable number of remaining tasks that we're checking whether it's 0 or not. And if it's 0, then we break. Okay. So we'll set number of remaining tasks equal to end tasks. I think we do colon equal.
That's right.
But we're going to need to call get a worker that's not busy, probably from the register chan argument here,
yeah.
Which is a channel like you were looking at. And then once we have that worker, then we can send RPC to worker with file name to be worked on. In our for loop, we can just get all workers that are not busy. And then also within our while loop, get workers that have finished tasks. Finished tasks of workers. So there's got to be some way for us to pull our workers to see whether the RPC that we delegated them is done or not.
Yeah.
And whether it's succeeded or not. And that's kind of how we'll handle the case where workers might fail to do the RPCs we delegate them. And once we get finished tasks of workers, we can decrement the number of remaining tasks numbers. One other thing that we definitely need to do is keep track of which inputs, which map files are currently being worked on. Does that make sense?
Yeah.
So we could do something more complicated, like a mutex to, track locks on which map files are currently being worked on by workers, or we could do something simpler, like create lists of like map files being worked on. and that could be an array of strings or whatever.
Yeah.
And map files finished. I don't know if we'd need that actually. But basically we would remove map files from the list of map files we worked on and add them to our list of being worked on.
Okay.
Rather than getting into the more complex stuff of like locking and whatnot.
Yeah, let's try that.
Okay. I mean, these are tentative variable names. We might come up with better ones in a little bit. But, so let's check out some of the contents of Common RPC, because we don't need to make any changes to Common RPC, but there's definitely a lot of info in this file about how to invoke workers.
Yeah.
And send them the MapReduce tasks to do.
Yep, we're gonna need the args for sure.
Yeah. Oh yeah. That's the struct that is passed as the second argument to whatever RPC that we're delegating.
Yeah.
So looks like a call. So we just really are just getting a list of available workers from register Chan. I don't know how it works, but I'm guessing that might be how it works. Once we have available our workers, we're just doing we're looping over I forget their fork syntax, but we're looping over the available workers and delegating them tasks. So I think it's just going to be call the type of task. So and then ours. You're saying worker dot.
I forget from the documentation. Worker dot do task.
Task. That defined somewhere in here. I know it was here in the docs here. Oh, do task. Worker.doTask. Okay, the first argument is the worker's address is read from. This is some address identifier for the worker. We can make our variable names super explicit.
Okay.
And then we have the arguments that were to pass to the RPC.
Yeah.
In our case, well, we can look at the struct. The job name can just be the job file, the map file name. Yeah. Okay. I mean, the job name and file can be the same. Only for map, the input file. I would guess that for reduce phase, we also need to specify input files. So I'm wondering why it says that comment.
Or maybe it can be inferred from the task number in the reduce phase. I'm not sure.
Maybe. Oh yeah, that's probably if we use a understandable convention for naming our intermediate files.
Yeah.
And passing from map to reduce, then yeah, I think you're totally right. But args will equal this do task args. I have no idea how to instantiate this struct.
I think that's great.
Job name, we can just make it the file name.
Maybe we should just try to call this with like the first file in the array and just see if we can get this working.
Okay. Map file 0.
Yeah.
File equals map file 0. Phase is this phase variable, which is passed in. And it's what phase of the MapReduce we're on.
Yep.
And then task number, I have no idea. Just make it 0. Num other phase.
I think you need phase equals phase.
Ah. Oh, these are all capitalized.
Yep.
Does this look? I don't know how to instantiate a struct, but
I think
does
that
that look great?
Yeah.
Going struct. Go by example. Okay. So here's an example of the struct. Oh yeah. Oh, it looks like we don't need to specify the field names. That look okay? This looks pretty jank, to be honest.
I don't know. Let's see. I don't know. Let's see if that compiles.
Because the example over here of a person struct with these two fields looks like it instantiates fine without.
Oh, it looks like you could do the name.
Yeah, it's optional. It looks like.
Yeah.
Yeah, we can do it, but we did it with equal signs instead of colons. Oops. Okay. The other thing we don't know about yet, or are not familiar with, neither me or Ben, about how to use this register chan variable, which is passed as an argument to schedule. Register chan is a Go channel object. And if I'm familiar with channels at all, it's that there's some type of variable that can be passed through the channel. So the channel itself has these RPCs where you can, it's for message passing between threads.
Yep.
So whew, can we go check out Golang channels? This is gonna be freaking brutal, man. Maybe there's some links to the appropriate docs in the lab notes. If there are, I haven't seen any.
You'll find the Go statement useful for this purpose.
Concurrency and Go. Whew. Concurrent programming is a large topic, and there's space only for some Go-specific highlights here. Shall we? I don't know. It looks like channels are mentioned down here. Should we just read this whole block about concurrency?
Yeah.
Okay, I'll make the font size a little bit bigger because I know I'm on a larger screen and not super readable. Looks like I lost where we were. Here we are. So, okay, concurrent programming is a large topic, and there's space only for some Go-specific highlights here. Concurrent programming in many environments is made difficult by the subtleties required to implement correct access to shared variables. Go encourages a different approach in which shared values are passed around on channels, and in fact, never actively shared by separate threads of execution. Unlike, for example, the Python Flask web framework, it uses globals pretty horrifically. Only one Go routine has access to the value at any given time. Data erases cannot occur by design. To encourage this way of thinking, we have reduced it to a slogan: do not communicate by sharing memory, instead share memory by communicating. This approach can be taken too far. Reference counts may be best done by putting a mutex around an integer variable, for instance. But as a high-level approach, using channels to control access makes it easier to write clear, correct programs. So this only bears true in the case that we're doing what we're doing right now, which is we're trying to write multi-threaded stuff.
Yep.
One way to think about this model is to consider a typical single-threaded programming running on one CPU. It has no need for synchronization primitives. Now run another such instance, it too needs no synchronization. Now let these two communicate. If the communication is the synchronizer, there's still no need for other synchronization. Unix pipelines, for example, fit this model perfectly. Although Go's approach to concurrency originates in blah, 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 blah. Okay, non sequitur. It can also be seen as a type-safe generalization of Unix pipes. All right, cool.
Okay.
Am I reading this one?
Sure. They're called Go routines because the existing terms, threads, coroutines, processes, and so on, convey inaccurate connotations. The Go routine has a simple model. It is a function executing concurrently with other Go routines in the same address space. It is lightweight, costing little more than the allocation of stack space. And the stacks start small, so they are cheap and grow by allocating heap storage as required. Go routine are multiplexed onto multiple OS threads, so if one should block, such as while waiting for I/O, others can continue to run. Their design hides many of the complexities of thread creation and management. Prefix a method call with Go keyword to run the call in a Go routine. When the call completes, the Go routine exits silently. The effect is similar to Unix shells and notation for running a command in the background.
So it sounds like when we invoke our workers or do this call, we need to just do go call or something like that.
Yeah, I think we're going to do go call. Or I think we're going to probably pass in a custom function.
Oh, okay.
Let's try to find
a function literal can be handy in a Go routine invocation.
Yeah, so there's go by example / channels. Go by example.com / channels, I think, has a good example. I'll put the link in the chat.
Okay. Oh, so you can declare a function like and call it immediately, like you were just describing. So we can do go func and then do our invocation of call somehow like that.
Yeah, and then when that returns, I think we can put something in the channel, like that would be then the thing that's done, maybe.
I'm
not sure.
Or we could re-register the worker address with register chan. You know what I mean?
Yeah.
Like we could say this worker address is now ready again for receiving RPCs. Something along those lines.
Yeah.
We can leave it as is like this for now while we continue to blindly stumble along through understanding Go concurrency. But yeah, and we need, it's kind of like JavaScript ify statements where it's a immediately invoked function expression. In Go, function literals are closures, like ifs. The implementation makes sure the variables referred to by the function survive as long as they are active. Okay. These examples aren't too practical because the functions have no way of signaling completion. For that, we need channels. Awesome. Dude, you're freaking psychic. Like maps, channels are allocated with make, and the resulting value acts as a reference to an underlying data structure. If an optional integer parameter is provided, it sets the buffer size for the channel. The default is 0 for an unbuffered or synchronous channel. Okay. Unbuffered channels combine communication with the exchange of a value with synchronization, guaranteeing that two calculations or Go routines are in a known state. There are a lot of nice idioms using channels. Here's one to get started. In the previous section, we launched a sort in the background. A channel can allow the launching Go routine to wait for the sort to complete. Okay.
Okay.
Whew. Dude, I feel like there's a lot of rote knowledge that you and I don't have about the particulars of Go concurrency syntax.
Right.
It's like while we're reading about channels here, we also need to read about RPCs because
there's definitely concepts here that we have to like familiarize ourselves with.
Yeah, such as engineering.
Right.
Oh my God. Okay, so we can walk through this line by line. So in contrast to how to make structs or instances of structs, we use this special Golang make keyword.
Yep.
And we're specifying that since there's no second argument, the second argument's assumed to be 0. So the channel will act in an unbuffered way, meaning we won't have to explicitly flush messages to be passed through the channel. It's hard to elaborate on that without having to go and dig into Wikipedia some more. Anyways, we have a variable named C that is this channel for passing integers. Start the sort in a Go routine when it completes the signal on the channel. So here we're invoking Go thread, or I'm not sure what the unit, what do they call it? A Go routine? Yeah, this is a Go routine. So we're invoking list.sort in a similar way to down here where we were looking at we were talking about how we could call go func and do our calling of the RPC here. And then we could say at the end of our go routine, send a signal back through the channel. Here it's saying that this value does not matter that we're sending back into the channel. This is, for example, remaining in a for loop. And then this is handling the return value, or the first return value being passed back from the channel. So we could say registered chan. Oops. We could be sending back our worker address ID. And then towards the end of our for loop, oh, this is looping over available workers, right?
Yep.
Something like that. I'm really not familiar with my Go syntax. Is this how you loop over? I mean, we'll see what register chan, how register chan works, how for a given channel you can retrieve all of the pending messages.
Maybe we should comment some of the stuff out and just print, like just start logging some stuff.
Okay. Oops. What shall we log?
So how many map files do we have?
Okay. So before, well, we can also comment out the infinite for loop. Yeah, I'll do that real quick. Oops. And these are also variable names that I made that we don't necessarily need to use. So you were wondering about number of map files.
Yeah, or like if we run this, or yeah, maybe we can just print out the map files.
The map file names?
Yeah.
Cannot use map files as type string and argument to, ugh. So is there, how you can't even print a list? That freaking sucks. For or map file, for f in range of map files, we gotta do this.
Yeah, I think so.
I'm not sure if this is the right syntax for looping over a range. Oh, we got to do colon equal. So okay. We know how to print ln instead of print f, I think. So they're printed to new lines. Okay, that's a lot. That's a fair amount of.
Fair amount. And then how many? Okay, schedule reduce phase done. Okay.
So that was the input files for schedule reduce, and here's.
Yeah.
Ugh.
Okay, so
50. It's like, or 100. 100 IOs. 100 IOs with 50 tasks.
Okay.
Not sure how that works.
And then what I was thinking is maybe we can just try and call like for the first file, just try and get that call working?
Oh, to the RPC?
Yeah.
So to get that call working, I think we need to use register chan, the channel with addresses of our workers, to get an address of a worker to be able to invoke
So
the RPC.
So pull a message off the register channel.
Okay. So we probably need to declare a variable like worker address ID, and then call worker address ID register chan.
Yeah.
That's the syntax. If we go back and we look at how channels work. Yeah.
Okay.
This is not doing anything with the return value. This is a really weird operator. But yeah, let's also try printing.
I'm just trying to understand, like, what's the data we're getting here?
Yeah. We'll give that a shot.
Yeah.
Unexpected new line? What the fuck? Line 27? Unexpected type. Oh, when we declare this, we got to declare a type, which I think is string.
Yeah, I think it's a string.
Is this the right syntax? Declare
above, yeah.
Again?
Var in tasks. It's a similar syntax.
Oh yeah, up here. Yeah, this looks right. Let's give the test a run again. So now we're getting a little further. Line 33, invalid character, literal, more than one character. Line 33. Oops, had extra prints.
That'll do.
Okay, line 32. Invalid operation. Send to non-channel type string. So we're probably using this less than dash operator incorrectly.
Okay.
Well, this is just saying it's discarding the sent value. What we could do instead, one thing that catches my eye is there's no space between less than dash and the channel variable name.
Okay.
Maybe if we remove the spaces, it'll start working. No. Worker address ID, I guess, needs to be.
Maybe let's not declare work address ID and let's just colon equals.
How's that? You mean like that?
Yeah, I think so, yeah.
Give it a shot. Invalid character literal, more than one character. Oh, maybe it doesn't like print lning fetch this variable type, whatever type it is.
Yeah.
Well, let's just Google real quick. Golang read value from channel. Read from channel. It looks like you're right. This is how we read from a channel into a variable. It looks like X and Y are not previously declared, so we do colon equals.
Yeah.
And that's what we're doing here. We don't have a space between the less than dash and the channel variable.
Okay.
Weird. So the error we're getting is not about reading from the channel. We're now getting an error about invalid character literal, more than one character. And that's on line 33, which is where our print statement is. Maybe I'm printing incorrectly. What if we print the string and the variable worker address ID separately?
Okay.
Let's see what happens. Line 33 is still problematic.
Okay, so wait, what is line 33?
It's just printing worker address ID, the string. But I'm using single quotes. Maybe I need to use double quotes.
Oh,
I don't know. This stuff's crazy. Oh, that worked. It was the quotes.
Okay.
Okay. So let me clear the output so we can see where Where the hell things are going wrong? So the print statements we just added here. Cool. So we are able to read the addresses of workers from the channel.
Okay. Okay. So maybe there's a way that we can get the length of the channel.
Probably. Billing read from channel until empty.
Yeah, something.
That's attractive. Or you're saying channel length, but billing channel length. There's probably, oh, there is length. So
can we just see the length of the channel?
Sure. Let's try that. We don't even need to do this inside the for loop.
Yeah.
In fact, let's do that up here.
And again, I'm just trying to understand like the things that we're getting past.
So yeah, length of channel. So we can just do length of register chan.
Okay, and then let's also do that once before.
Yeah. So yeah, we're just trying to see whether reading something from the channel decreases the channel's length.
Yeah.
Any guesses about what the length of our channel is?
Well, I don't know.
Probably has something to do with these.
It probably has so these are the map tasks. It really is a question of how many workers we started.
Yeah. Is there somewhere in here in our test output that hints at how many worker instances we're allowed or have? Looks like 2.
Oh yeah, 2.
So I would guess 2.
Oh, cool.
Let's give it a shot. Length of channel, 0. And then we're able to read from it, and there's still length 0. So
okay,
length of channel seems.
Yeah. So wait a minute. Let's go back to that.
Go back to the output of the test.
So we had length of channel. So then we had a register worker after that. So this is all happening asynchronously.
So we are.
So then we pulled off the.
Got it. And then.
And then we did it again, but we already pulled the one worker off, so it was 0.
And then here is where the second worker gets registered.
Yeah.
So maybe we can do a infinite loop like we did down below, and we sleep for a second or two between this loop.
Or maybe we can look up syntax for like block for a channel input. Maybe there's like.
So it would block here.
Oh, so it blocks there. Okay, cool.
Yeah, I would guess it blocks here, and that's why we're able to get this at all.
Yeah.
Is that we block. So we can do do you mind if I do a for loop?
Sure.
For true, and then we'll add a sleep at the bottom. I'm not familiar with adding going sleep, but there's probably, time. We might need to sleep. Got it? So it's in milliseconds, so we want to multiply it by 1,000 or whatever. Is that right?
I'm not sure.
Duration D. They don't give any hint at what the duration is. Nanosecond count. Jeez Louise. What the H? Oh, we can multiply it by seconds, time.second.
Oh, that's nice.
So we can do time.sleep. Let's just sleep for 1 second. We need to add that import time. So what we're doing is we're doing an infinite for loop, checking the length of the register channel variable, trying to read a value from the channel, and then sleep a second before retrying the whole thing again.
Okay.
So we're sleeping a second. Length of channel 0, 0, 0, 0. Whoa, why did it stop?
Oh, we printed out both.
Yeah, and we're blocked on line 38. We're trying to read from a channel that doesn't have any messages to pass yet, so
okay,
our thread's blocked.
Okay.
Okay.
Okay, this is starting to make sense, I think.
Yeah, so getting the length of the channel is not inherently super helpful for completing a lab, but understanding what the hell a channel object is helpful.
Yeah.
Let me close a bunch of these because we don't need them. Now that we have, now we understand how to read worker address IDs from register chan, we have an idea of how to delegate an RPC to one of these worker address IDs.
Yeah, so I would say next step is let's just get the first worker address ID, like not necessarily in a for loop, yeah.
Mm-hmm.
And let's just try and make sure we can call the call function correctly.
So I believe it's going to just be call.
Yeah.
The worker address ID. So just to give people context, we're looking over here at the signature, call signature of the function call.
So SRV, is that short for service?
Probably server, yeah. In our case, it's a file name. Like on Linux file systems, everything is a file. And since our lab is really just running on our laptop or our runtime environment and not on an actual distributed system with multiple servers, our address ID is not a URL or an IP address, but it's rather a file name.
That's it. So maybe the RPC is actually just writing to that file, and then the worker is like, or the RPC framework is reading from that file.
Potentially, yeah.
Do the work.
Yeah, because that's what this line RPC.dial looks like it's doing.
Yeah,
is it's taking a Unix socket, I would guess. So the file name is probably a Unix socket for passing input.
Okay, this is making sense. Okay, we're making progress.
So we call giving the server name of our worker, right, in this case, a Unix socket. We tell what phase of the MapReduce we're on. We need to pass a do task args object, which we had written before or instantiated before.
So phase is actually going to just be worker.dowork.
Ah, that's a string.
Yeah.
Excuse me. And then our third and fourth arguments are that do task args. So I can just copy this. Ooh. So I'll just say args. I need to use colon equals. We also don't need time anymore. I'm now getting a lot better at identifying or forecasting what kind of compile time problems we're going to have with Go. Args, and then the third argument is this reply, which is an interface. So it looks like reply is passed as an argument to the RPC object, C. And it's probably, well, I don't know. Ben, are you familiar with interfaces in Go?
Well, an interface is just, well, I think it just means it implements a certain set of functions.
Yeah, yeah. So if we go look at the Golang RPC docs for dial objects and their call method, or whatever dial's return values type and that type's call method, they might have more information about what type of interface our reply variable needs to look like. If I had to guess, I would guess that reply is probably a channel.
Yeah, that would make sense.
We'll go do what we're just describing, Golang RPC. We'll look at dial, the dial method, or dial, whatever. Looks like it's a method on the client type. Looks like we're calling RPC.dial though. Am I missing something here?
Can you go back to the code?
Sure.
So
RPC, I believe, is
where is reply being used?
being passed as a third argument to c.call. And RPC.dial looks like it's a function in the RPC library.
So it actually might be let's go back to
the
code. So we have do tasks args. Do we have a do task reply?
We have a shutdown reply.
Oh.
We have register args as struct. So just for viewers, this common rpc.go file that we're editing right now, we actually don't need to make any edits to finish this part of the lab. We pretty exclusively only are needing to modify schedule.go. We can, of course, add like print statements here or whatever, but we shouldn't need to make any modifications.
Yeah, I'm not sure what reply interface means, because args is also an interface, so I'm guessing that reply is like a pointer to a struct that we want the RPC to fill out, maybe?
Oh, that would make a lot of sense. Yeah.
But I don't know what so that's why I was asking if there's like a reply struct already built for us.
It
looks like there's a shutdown reply.
Let me get rid of all our all the mumbo jumbo that we wrote earlier that was before we knew anything about Go channels.
We were a little too ambitious earlier.
All end tasks have to be scheduled on workers, and only once all of them have been completed successfully should the function return. Remember that workers may fail and that any given worker may finish multiple tasks. So like you said, the args argument and reply argument to our RPC call function are both interfaces, and our args argument is this do task args struct. And the do task args struct is just a struct, so maybe there is some type.
Maybe it's a shutdown reply?
Shutdown reply? Okay, well, do you think we need to instantiate reply, you know, like
yeah,
reply, and it should just be 0?
Yeah, I'm not sure. Maybe we should just, yeah.
So call, it returns true, false, a Boolean. So let's try, and if the RPC succeeds, it returns true. So this is the actual calling of the RPC.
Okay.
So it communicates with our worker. So this call function that was written by the author of this MIT lab is a wrapper around the Go core library RPC library. And this is where the actual call over RPC is done to our worker at its given address. So returning true, so we can say succeeded, something like that. We could print that. Is that good?
Yeah, I guess.
I won't make that mistake about single quotes versus double quotes again.
Yeah, you won't make that mistake once.
So let's see if we can effectively call the RPC. Yeah, the space there. So this is something about programming in Go that kills me, is that while we have these two files open, we have schedule.go and common rpc.go files open, they have this line at the beginning of the file called with a package name declaring that they're in the same package.
Yep.
And just by virtue of being in the same package, anything we've declared in either file is available to either file. So this call method, it's like, where's that coming from, you know?
Yeah. And especially like call is such like a common term. Like it's not really clear that this is a MapReduce only type thing.
Yeah.
Or our package only.
So ambiguous.
Yeah.
Why can they call it like, in, you know, RPC call or like, I don't know. Yeah, you got it. Shall I try running the test again?
Sure.
Will you bet me $1 that this works?
I'm gonna bet that it doesn't work.
All right. Oh, Venmo me. You're totally right. Unexpected new line, expecting comma or colon. So line 42. What did I do here? What did we do here? Maybe there's, so we didn't have a comma here before. Maybe we need it.
Maybe we need a comma there, yeah.
Yeah, that looks like it was the issue. That's really interesting.
I personally like that.
Having a trailing comma?
Yeah, because like otherwise, if you want to add something to the struct later, it's going to change both lines when that's not really the case.
Yeah, I agree. I mean, it leads a little bit of confusion because it doesn't line up with English language commas, but I agree. But we got a little bit further. Let's see what printed. So it did not succeed. Oh, can't find method. Can't find method worker.doWork.
Oh,
super interesting.
Okay.
Okay, so the RPC name here is passed to rpc.call.
Okay.
rpc.call, well, we need to figure out how.
Do task, sorry. Worker.doTask.
All right, let's try this again.
That's helpful.
Ooh, we got a lot farther. What are we doing here? Printing out all these things. Where's that coming from? Oh, that might be from our previous parts of the lab where we were printing out as debugger statements.
Oh, okay.
Maybe we can go into common map and see where we're printing. Probably log. It's only log statement. Maybe funct. We're also not printing in here. Maybe we added it somewhere else.
I think we added it somewhere else. I don't really remember. I think wherever we called do map, I think we added it.
That would be in common, I think. I don't. That's if debug enabled.
Can you do a search for do map?
Okay. So master.go, worker.go.
So I don't know whether it's mapper.
So we don't have any print statements here. I'm looking for funct mentions. No more in master.go.
What about worker.go?
Here's a print statement. Here's a print statement. We just wrapped around. Log. Yeah, there are only 2 mentions of log. Getting rid of those print statements isn't the end of the world. It might be something that the lab provides us by default, so we don't need to worry about it too bad. So maybe we're succeeding at invoking the RPC for one worker.
Okay.
This is debug information about the worker that we're calling an RPC for. Oh, this is when we are getting the first worker address. So currently, we are only getting one worker address ID, and then delegating it. Ooh, I'm getting some reverb on the Hangout. Are you on a speaker or headphones?
Oh, I'm on speaker.
Ooh. Do you have any headphones you can go grab?
Yeah, give me a second.
Sure.
How's this?
Much better, much better. So what I was doing now is, now that we have this list of map files, whether we're in the map phase or the reduce phase, I was looking into how do we remove the first item from the list of map files, and so that it's now removed from the list of map files we worked on, so it doesn't get delegated to be worked on by two different workers.
Okay.
So haven't gotten very far.
Okay.
What I was about to do was I was going to make the infinite loop again, and I was going to make that infinite loop not just access the first map file.
Okay. So wait, did we get the call function to succeed?
Yep. Yeah.
Can we also try to print out reply?
Oh, so succeed is returning false. Yeah.
Oh, okay.
We can keep going and try and figure out why reply is not or why succeeded is not true. But you're suggesting, oops. So printing out reply.
Yeah.
We might need to print out reply.end tasks, because otherwise it doesn't print out anything.
Okay.
Just the address of the struct.
Okay.
Oops. So printing out, currently when we call this, we're calling it inline or synchronously, where I think we're going to want to do go routine here.
Oh, right. Yep.
And that might be why succeeded is returning false at this point, or I don't know, we'll see. We were looking for where it print out reply. I'll just search reply. There it is. So it's performed 0 tasks successfully by the time that we print this.
Which makes sense because we got false.
Yeah. Whew.
Okay.
I don't know about in SF, but over here it's freaking cold right now.
it's chilly in SF as well, yeah.
Okay.
Yeah, it seems like we should try to figure out how to get this call to work before we kind of move on, because otherwise we won't be able to tell.
Well, let's read this documentation string for call a little bit longer. So call sends an RPC, a remote procedure call, to the RPC name handler on the server SRV with arguments args. It waits for the reply and leaves the reply in the reply variable, which is what we were talking about earlier. The reply argument should be the address of a reply structure, exactly like you said.
Oh, so maybe we have to do ampersand reply when we call it?
To give the address of the reply? Maybe. I mean, in order for it to be written to by the call method, we can give that a try. I mean, yeah. Still getting 0. Okay. So I'm not super familiar with my state of the world with Golang and what variables you can use ampersand to get at which ones are basically which types of variables are pointers or not.
Yeah.
Call returns true if the server responded. Right now we're getting false. If we look at the output here, oh, never mind. Succeeded is true here.
Wait.
Notice that? What do we do differently?
Wait, did you rerun it?
Yeah. Oh, now it says false. What is going on? Oh, that was with the ampersand. Maybe the RPC is failing, and it fails very quietly. And because this, like you suspected, is not a pointer to a reply struct, this error was non-null, and so that's why we're.
Wait a minute. So if we go back to
reading body gob, attempt to decode into a non-pointer. Dude, you're totally right.
Okay.
It was totally that ampersand. Good eyeball, dude. Fucking nice.
Okay.
All right. Yeah, now I added the ampersand back and we're getting succeeded true. We're no longer getting that warning about unable to gob or whatever. Gob is probably referring to like a unstructured portion of memory that we're supposed to write the result of the worker shutdown to. There you go, dude. Nice.
Yeah. So I'm still not sure we're using the correct struct, but I guess it's working.
Yeah, because we're not getting the number of successful tasks back.
Yeah.
Although this is the reduce phase. This is the map phase. So map phase should succeed. Like this should be one. Like the worker should have done one map task.
Right.
Since we are, after all, invoking map tasks to be done. We're also setting these variables probably wrong.
Okay. Maybe we should set those correctly.
Yeah. So task number is this task's index in the current phase.
Okay, so that's 0.
That is 0 because we are hard coding to get at the first map file.
Yeah.
And then number other phase. It's the total number of tasks in other phase. So I think that's reduced if we're in the map phase and vice versa.
That's just going to be our in other.
Oh, right on. Mappers need this to compute the number of output bits. Oh, there we go. So we're not actually writing any output from our map task because we hadn't set that map variable properly.
Okay.
Reducers need this to know how many input files to collect. Okay.
So now if we run that, maybe
we'll get a reply that the worker has processed one map task.
Yep.
Oh. Well, we're getting a panic now that there's no output being written or no file being written to.
Okay.
That's progress, I think.
I guess.
We're probably not blocking our schedule function on workers being complete with their tasks. So we're progressing from the map phase to the reduce phase, and the reduce phase is trying to read the map output before the worker has even, our one worker who we've hard coded has even completed the map phase.
Oh, interesting.
So our worker would write to this file that the reducer is trying to read from.
Yeah, so we're in the reduce phase now. Did we get a true? No, so we still got 0.
Well, probably because this value hasn't been written yet.
Okay.
Yeah. I don't think we're doing a lot of things asynchronously, implicitly that I think both of us are just super unfamiliar with.
Yeah.
So we definitely need to block on some way of telling the state of our program and its progression through the map files.
Okay.
Right now we're working on one map file, and we have no idea whether this has finished or not by the time it returns. Because as soon as this returns, our schedule is just done. You know,
right.
Our scheduler just finishes immediately. So we probably, and this is where channels probably come in. We probably need some way to message pass. Well, it seems like the succeeded. This would block. If it seems like this would block.
Yeah, I think that will block. We're not. RPC should, in nature, be blocking. I think.
Well, the other warning we got about this lab is that we should be delegating work to more than one worker in parallel. And because we suspect this blocks, we're not doing that currently.
Right, totally.
And that's where we were talking about earlier about running go call. Maybe we have to do this.
Yeah.
Whatever. So this invocation of call will be non-blocking.
Right.
We'll need to message pass from this back to our main thread, which is evaluating our schedule.
Well, so maybe. Okay, so I think it's, first of all, I think it's just go func. I'm not sure if it's function. So maybe what if we add, after this call, we add back on the channel the worker address ID?
What's your suspicion there?
So then we can have a loop that's just like, give me the next channel that's available. I do the work, and then I put it back on the channel that's like back on something that we can work.
So this is, I believe, non-blocking. So if we put the worker address ID back on,
no. like after the call, directly after the call.
Oh, right here. Ah, good call. Yeah. So we're gonna put the worker address ID back into the channel.
So it's like you pop it off because it's working, and then when it's done, you pop it back on.
Yeah. Okay. So this will be non-blocking.
Yeah, and so basically, I think, and I don't know if this is correct or not, just hypothetically.
Sure.
If we do a while loop over this whole thing, right? Then we're popping and blocking for available workers. We're doing work, and we're putting it back on. So that should just pop and kind of do work.
Pop and block.
It should do a classic pop and block.
Classic. Okay.
And then, but we need to bail out of this at the beginning if we've done all the work. So we have to figure out a way to track it.
Yeah. So we could do that using counter, which is like num tasks, end tasks completed. But because we got above us, we have our end tasks variable.
Okay.
And we could set that equal to 0. And we could say if end tasks completed equals end tasks, that's our condition for breaking out of the for loop.
Yeah, something like that.
And over here, we could say, succeeded.
Oh, yeah, there we go.
If succeeded, then we increment and tasks completed.
Yeah.
However, one thing we are not doing is we're not incrementing the map file to be worked on.
Oh, right. Okay.
So
maybe we can just do in tasks completed there.
Oh yeah, we use totally good call.
Actually, no, that might not work.
That would be delegating the same task to.
Yeah.
What if we have a current task? That doesn't work in the case of part 4 of the lab where we need
failures. Ooh, tricky.
Yeah. What if we kept some type of struct or data type that keeps track of outstanding tasks that have been delegated?
Yeah. I mean, we could do a
some kind of set.
Yeah, set.
I don't know data structures and going that well. What we would do is yeah, this is really a Go programming language data structures tutorial for me, man.
Right.
Doing this in Ruby or JavaScript or Python, I think both of us would be pretty.
It'd be a lot more straightforward.
Yeah.
Okay.
So our problem right here, we might not even need to do, we could do this inline, I think, but now this is already pretty long. Our problem right now is this index number, so.
So wait, what if we approach it in a different way, this whole problem?
Okay.
What if, okay, bear with me.
Okay.
What if we start out by default, we just loop over all the map files, and then we create a bunch of Go funcs for each one of those. And then within each of those Go funcs, we actually block for a for a worker that's available.
That's a good idea, or an interesting idea.
Well, it's an interesting idea. I don't know if it's a good idea.
I mean, what the downside to that is obviously
if we have a shit ton of
and Go routines for end tasks.
All right, maybe it's not a good idea.
So I guess let me provide an alternative. The alternative is to do what we were headed towards doing with our tracking of outstanding tasks, meaning ones that are currently being worked on by workers.
Yeah.
For which we do not know yet whether they've succeeded or failed.
Okay.
And we need to, after getting an available worker address, a worker that's not busy, we need to get next map file.
Yeah.
Or get next task. So we need some function or some way of getting at our next task.
Yeah.
And that could be done by looking at our map files and our outstanding work, and taking the diff to get map files that are currently not being worked on. And the thing I'm obviously leaving out is also map files that have already been processed.
Okay, so wait, what if we okay, what if we create an array that's of integers, the same length as map files?
Okay.
And to start, they can all be zeros, which means the corresponding index has not been started. And then we could just do like find the index of the first 0 that you see, which will just be the first one.
Mm-hmm.
Do work. Mm-hmm. Set the value of that index of that to like 1, which means like, it's currently being worked on. And then if it succeeds, we can set it to 2 or something. And then if it fails, we can set it back to 0. So it's kind of like a bit mask or something. Does that make sense?
Using that variable as our tracking of finite state.
Yeah, it's kind of like a set, but I think it'd be easier to work with.
Yeah, so in fact, with structures, instantiating what you're describing, like a task, like we would say end tasks, right? We would say something like 0 unstarted, 1 in progress, 2 complete. Yeah, something like that. So, like you were saying, Getting next task would be find index of first 0.
Yep.
Or of next 0 in task state array. Effort?
Yeah, I think that.
So,
I mean,
yeah,
I don't know.
Is this an array or a slice? I get confused between those two. Let's look at Golang slice array difference. So one of them pre-allocates in memory, and the other is dynamic, of dynamic length. And I think slice is pre-allocated, array is dynamic.
Okay.
So an array, you need to, yeah, we're dealing with array. Is that right?
Yeah, I think so.
So when we instantiate this array, I don't think the default value is 0.
0, yeah.
So we might need to Golang array of zeros. Fill its slice with values. There we go. God, I hate Google Groups. This is one option, yeah.
Okay.
We can just do that. Sounds good to you? Sounds good to you or me?
No, yeah, that sounds good.
Okay. Make sure I got tabs and spaces set up right. Yeah, cool. So instead of R, we have task state. So getting the next task to be worked on probably involves.
So it does bracket in tasks, that makes.
That allocates an array of length number of tasks.
Gotcha.
Which is
okay.
The length of our map files argument.
All right, perfect.
In the case of the map phase, and it's the number of reduced tasks in the case of the reduced phase.
Okay.
So depending on what phase we're in, we may or may not need to provide this argument. But what we're doing here is we'll change this to next task. Next task. Let's see here. So we just need to get task state index of 0, and we'll get the first occurrence of.
Oh, 0. So there's no helpers to do index of.
Awesome.
Which is what I was hoping that there were.
So we can do for I in or I range of n tasks. Yeah.
Yeah.
If n tasks I equals 0, we can say next task equals I.
Yep.
Otherwise, and we can break.
Yeah.
Otherwise, if outside of the for loop, if next task equal nil, then we can break out of our infinite loop.
Yep.
I think I'm using colon where I should be using curly braces.
Okay, cool. So now we don't even need in tasks completed, maybe.
Yeah. We can get at in tasks completed by looking at our task state array.
Yeah.
You can say how many.
Maybe we should do this before we block on a channel.
Yeah. Good idea.
Okay.
The other thing we could do is, like we were just talking about, we could print the number of every time we go through this for loop, we can print out the number of tasks in different states.
Yeah, sure.
That might be premature though. What do you think?
Maybe we can just print out like does Go have like, can we just join the array with commas or something?
Well, it's gonna be like 100.
Yeah, like maybe we can just print out the first 20 joined with commas. I don't really know if there's a way to do that.
Yeah, there's definitely not. You're saying like get the first 10 or whatever.
Yeah.
Yeah, bad. Yeah, definitely not. Freaking Go, man. God. I'm sure.
Oh, wait.
About the for loop. What's that?
Strings.join.
Going strings.join.
Yeah.
Takes a separator, or it takes your array and then, or your slice type, which includes array.
Oh, it has to be an array of strings.
Don't we have? Oh, we have integers. Yeah, we would need to like map over our array and cast them from integer to string.
Okay. Maybe let's just not do that right
now. Yeah. We could leave this print statement saying that we're at the top of our while loop.
Okay.
Everything here look good. I'm suspecting that we're going to get an error here because we're doing a variable declaration inside of a for loop. This may get invoked more than once, and the compiler may be able to detect that. And declaring a variable twice in this way is like a big no-no.
Maybe let's just leave it there and see, because we need it to be nil, right?
Yeah, to be able to break out of our while loop.
Yeah.
So, I mean, we could set that to
we
nil
could set
every
it
time.
to nil. Yeah, maybe that's safer. Okay.
God, gotta add more print statements.
I have no idea if any of this is going to work, but I feel good about it.
Yeah, me neither. Well, I mean, let's think about our state of the world. We now have this array which keeps track of state of outstanding tasks. What we're not doing is we are not updating task state.
Yep.
So in our Go func, or before our Go func, since the Go func is asynchronous,
yep,
we absolutely probably after we get the next worker address ID available,
yeah,
we need to update task state for the next task, which is this integer, so the index. We need to set its state to be in progress. And then lastly, before we don't need this anymore, well, if succeeded, we need to change the task state again to be 2. All right.
Yeah, I think so. I'm not sure if we should do the update of the task state to 1 before we get the channel or after.
Yeah.
I don't know. That's
tricky. I don't
tricky.
think it matters super much.
Let's just do it before and see what happens.
Okay. If succeeded, we may be able to solve part 4 of the lab already. We can say else. We can reset the task state to 0 if it failed. So making it available again to be worked on.
Perfect.
Okay. So we can probably get rid of this. These print statements.
Okay.
We may want to put that in here. I think it would be better to put this all in one line. Are you familiar with Go print statements?
I'm not, no.
Let's take a look at that real quick.
I thought we could just do comma separated, but maybe not.
Print interpolation. Interpolating the values of other arguments into this.
Yeah.
Format a string without printing? We just want to format a string. Golang print format string. Oh, man. It looked like there actually was an answer here. %v. Oh, v is for value. That's what we want to do.
V can take any?
Yeah.
Okay. Let's also print out the index there.
Which would be, oh, we're not passing it in as an argument. So we need to probably pass in next task.
Ooh.
We can probably just declare it. And then we can say,
okay.
you see I'm naming it differently than next task?
Yep. Makes sense.
Give this a try.
Yep.
Getting some audio buzz. It might be your collar.
Oh, sorry.
So, shall we give this a shot?
Yep.
This is where we are re-registering the worker address ID back onto the list of available workers, or the channel of available workers. Every time we go through the while loop, while things are being worked on in Go routines, we check to see if there are any, in this case, we're going to be breaking out of the loop in the event that there are still tasks being worked on. So we need to say, basically, we need to have a flag that says finished or something, which in this while loop checks if all tasks.
So actually, that's a good point. So the hint says sync wait group might be useful.
Okay, what does wait group do?
I don't know.
You may find sync.waitGroup. Okay, sync is another standard library package. A wait group waits for a collection of Go routines to finish. The main Go routine calls add to set the number of Go routines to wait for. Then each of the Go routines runs and calls done when finished. At the same time, wait can be used to block until all Go routines have finished. So that sounds like an option, and it sounds along the lines of what you were proposing earlier, which was create one Go routine for every map file.
Yeah.
Or similarly, it sounds like we could read off from the channel all available work address IDs, create a group of Go routines, and wait for all of the outstanding work to be done by available workers.
Right.
Which also doesn't sound the most optimal.
Yeah.
So this is a weird hint. I'm not sure why they suggest it. They say you may find it.
It does say you may find it, so it's not like this is dependent on that.
Yeah.
Okay, so wait, so you're saying that we could break before the Go routines are done?
Yeah, because we're only breaking out if there's no next task available, but there may be no next task available because there are still some remaining tasks that are in state 2, meaning they're still being processed.
So what we actually have to do is check to see if everything is in state 2.
Yes.
And then break.
Exactly.
Gotcha.
So we could be inefficient and just loop over end tasks again.
Right.
And come up with some condition in which we say all these have to be 2, right?
Yeah.
I think I have a syntax error here, which is I was using a colon instead of curly brace. N tasks I not equal to finished equals false. If finished, yeah. And at the beginning of here, we can say finished equals true.
Okay, yeah. Okay, I see, yep.
Yeah.
Yep, makes
It's
sense.
basically the same thing.
Okay.
We can probably put this on online. I think Go supports that. This is just saying at the beginning of our while loop, if anything is not equal to 2, then we're not done yet.
Yep.
But if everything is equal to 2, then we'll break out of the loop.
Yep. I like
so
that.
If this was like super mission critical important for a business or an airplane or something, we would write tests of this. Right now, we're just trying to get the tests
Right.
that we're assigned to pass.
Yes.
This look good to you?
Yeah, I have no idea if this is going to work.
I'm sure we'll get a syntax error.
That'd be amazing if we run this in like all the tests pass.
The reason why they definitely won't pass is because this file of our do task args is not correct.
But it is now, or it should be.
It says map file is only for map, or the input file. So we might need to not pass it, or it might get ignored. I don't know.
Only for map, the input file. Okay.
The other thing I'm noticing is that let's say we get to the state where everything but one task is finished. In that case, next task will be nil, but not everything will be done, and we'll block and wait for a worker to become available, even though we don't need to wait.
Oh, interesting. Okay.
Or actually, we'll get an error here that says cannot get index of nil.
Yeah.
So maybe
we should break if no.
Maybe if next task equals nil, we'll just continue.
Yeah.
This is going to be a long loop. No additional work waiting.
I mean, we could also sleep there.
Yeah, we could sleep there. We could also just not print anything. It'll just churn over these lines.
Yeah.
I'll just not print anything.
Well, if we're gonna print something, then we should sleep. Otherwise, we might just get like
a wall of text.
A wall of no additional work.
Okay. Time.sleep 1 times time.second, right? There's the syntax. We need to add time. Cool.
Cool. Oh, and now let's print something.
Oh, okay. No additional work waiting for completion. Yeah.
Yeah.
Dude, we've gone a long while without running tests.
I know, it's really scary.
Agreed. Oh my God. All right, let's give it a try. Definitely a syntax error. Yeah. Non-constant array bound and tasks. Non-constant. We might need to just define const task state length and set it equal to, and it's an int, and we need to set it equal to n tasks, something like that.
Yeah, or we might just be able to change var on int task to const.
Oh yeah, you're right.
Maybe, I don't know. Actually, no, because we're changing it. Never mind. Sorry.
You are?
Yeah, because we're
Oh
setting
yeah, because we're setting it here. Yeah. Yeah.
um,
How silly. Is that right?
yeah, I guess so. I have no idea.
Boolean const. Ugh. We don't need to say it's type, it looks like.
Okay.
Interestingly enough. You know it's an int. That's super weird. Const initializer end tasks is not a constant. Great. Golang set const from variable. Or Golang, what we really want to do is array length from variable.
Yeah.
You should use a slice. Great. Okay.
Oh, okay. Yeah, so
Maybe we should use a slice.
so we should just do make int, just like they have there.
And we need to make it, we need to instantiate it, basically.
Wait, is elms the
It'll need to be a list of zeros or array of zeros, I guess.
or is that the number of elements? I think in our example, it's just a number.
Oh, okay. Okay.
I think. I don't really know. Yeah.
Let's just print out task state. Yeah.
Yeah.
Good.
Yeah, looks good.
Invalid character literal, more than one character on line 44.
Mm.
Oh, that's my single quotes. Sorry. Cannot use nil as type int in assignment, line 45. Oh, we can't reset it to nil. Oof.
Oh,
how about we set it equal to -1?
Yeah, let -1. Cool.
Yeah. Into the file. Cannot range over end tasks, type int, 47. Getting closer. Range over end tasks is an int. Yeah, this needs to be an array.
Wait, we can't range over any.
We could range over task state, right?
Oh yeah, sorry, you're setting in tasks.
Okay.
Yeah, I think that makes sense.
Golang for range. Dude, I swear we looked at this like 4 times today. Yeah, that looks good.
Yeah.
Yeah. Okay.
All right.
We could, yeah. Our variable names needs a little bit of work, but oh, cool. We're getting quite a bit further. Starting MapReduce task. Here's our task states. Wow, it finishes with the loop a little too fast.
Yeah, done with loop after.
Yeah.
So
we're definitely aborting earlier. It finished equals true.
Yeah.
I'll add another, we can add another print statement here that can hint at when finished is false. This will print a lot though.
Yeah.
I think that Boolean statement we had before here,
yeah,
was just seeing whether this is defined or not.
Okay.
Like I'm not sure if it's
Oh, no, it's because we're never getting to line 52. I think we need to do that before the if.
Ah, good call.
Yeah.
Good call. That's totally it. It looks pretty good, but those numbers are going up really high.
Wait, no additional. Wait. Okay. Something's happening.
Yeah. Okay. So, well, let's see what print statements we're seeing.
Oh, wait, was that the reduce phase? I know.
Pretty sure this is the map phase.
Okay. I have to get a charger. I'm going to
Okay.
be back in just a second.
Okay. Hopefully we'll be done by then. What is that, audience? So what I'm doing here is that I am adding additional info to the tick step. So while we're in this for loop, we can see if there's some bad state that we're getting into as we're in that loop. So it looks like we are getting all of the map tasks into a completed state, which we're tracking in this task state array.
Okay.
However, we're not breaking out of the loop. We're getting here. We have to move this if condition before the other one.
Okay.
That was our problem. Yeah.
Okay.
Cool. I think we made maybe solid. Okay. Well, we're getting to the reduce phase, but we don't have any files. We don't have the intermediate files written out yet. So I'm guessing that we're using the wrong file names in the reduce step, is my guess.
Okay.
We are using the same file. Well, this file name here.
Yeah, so that doesn't look correct.
Yeah.
So I think, can we go look at the documentation for args?
Sure. That was in common RPC. So do task args holds the arguments that are passed to a worker when a job is scheduled on it. We have job name, file, phase, task number, other phase. So job name is, I don't think used for anything really. Just needs to be a unique identifier, ideally.
Okay.
And then file is only for the map step, because in the reduce step, I think the reduce step is inferring what the intermediate file name is that it's going to be working on from the task number. So the file name that the reduce phase is trying to open that's not existing. This is the.
Can you ls this directory? Can we see what files are there?
Woo! Let's see if there is that. Well, this is gonna be. Oh,
I guess they kind of look correct, right?
Yeah, they've got a map task number, I would guess, and then the map task number again, and then the target reduce task. That should be the one that is handling this intermediate file.
So it said that what file didn't exist?
This one. So it looks like, ugh, shit, I hit space and it took me all the way down. It was this one. So I'm copying this. So mrtemp.a24-mrinput-1. I believe this is the map task number. And then 0-1 is the map task worker and the reduce task number. So the reduce task number indicates a bunch of different reduce intermediate files that reduce task should be working on. And this is an example of a file name that reduce task is expecting to exist.
Right.
So we can ls for that file. No such directory. Interesting. So there's a bunch of other ones.
Yeah.
It looks like this number is not auto-increment. It looks like it is auto-incrementing. Let's see about all files that... oh, interesting. It looks like those two numbers are reversed. Like this should be 0-1, 1-1,
yeah,
10-1, 11-1, etc. So that might be our problem.
Okay.
So task number is this task's index in the current phase. So we're setting that equal to next task. Meaning, yeah, the task that the current phase in this task is to be working on.
The task's index in the current phase. Okay.
Do we have this backwards somehow? Task number and other phase are backwards somehow?
I don't know. It doesn't seem backwards to me.
What if we just flip them and see what happens?
It just doesn't seem...
Right, I know. It's weird. Shall I? Just for... That didn't take very long. Still a problem.
Did the file name that it's looking for change? No, it's the same one.
Yeah. Oh, yeah, no. Oh, I didn't change it at all. That's why. I copied pasted the lines, commented out two of them, and then didn't change them. This would be so dumb if it works, and I'd feel really bad. Okay, still a problem.
Okay.
Interesting. Only one file is written now.
Yeah, that can't be right. I think.
Yeah, definitely not right. I was just trying to be cheeky.
Okay, so let's see. So it's failing in the reduce phase. So what is map files that we're given?
It's it holds the names of the files that are the inputs to the map phase. MapReduce is the number of reduced tasks. Okay. Maybe we need to do similar to this switch statement here, but when we're setting do task arbs.
Okay.
So depending on which phase we're in, we have the case of map phase and the case of reduce phase. Depending on which phase we're in, we set the do task arbs differently.
So I think so. Let's scroll up.
Where at?
So while true, are we ever? Dang. Okay. So we are. So we're keeping track of map state, right? So task state is an array that's keeping track of the state of the map files. So in task,
or it's keeping track of the tasks.
Oh, okay. Yeah. So that should be working.
Yeah. I think we goofed up somewhere slightly with how we're using these arguments. Like we're using map files incorrectly somehow. Maybe this argument should be, we should try setting it to nil.
Yeah, maybe we should set it to nil.
Yeah.
And maybe job name shouldn't be map files next task. Because that's going to be nil each time.
Maybe just next task?
Yeah.
Do you think it's worth renaming the variable in the next task? Task to be worked on or something like that?
Maybe task index? I don't know.
I like it. I mean, next task is fine for now, I guess. Give that a shot. We're going to try running this again. Ooh.
So we got to convert it to a string.
Oh. Delaying cast int. I think it's just like string. Maybe we'll just do string or something like that.
Right.
Or string conf is what it is. String conf.i2a.
Wait, what? Oh, okay.
Integer to string.
Okay.
Why is it A?
I don't know.
Wouldn't it be S? That's super. Oh, I guess. Yeah, that's super confusing. That's super annoying. What is A?
Maybe it's a array of characters.
So, okay. We are succeeding in, it would be really nice to get rid of all these prints.
Yeah. Let me try and find out where we're doing that. Can you scroll up all the way to the top?
Sure. Oh. I suspect it's in our do map, like you suspected. I think you're right about that. Wow, this is a shit ton. Let me go.
I don't see anything in the code that I have, so you may not be committed or something.
I can push up to a branch, and I think when we started, I was sure that I didn't have any diff or anything pushing.
Oh, then let me maybe try to pull.
It looks like it's just printing out every line of the input files. I'll get that for directory. In CommonReduce, we print a file name. Common RPC, we print an error. Might be the worker, not worker address ID. Oh, it's number of tasks, maybe? No.
Maybe let's add a sleep in our loop.
Okay. Which loop? The for loop here?
Yeah, the for loop here.
Okay.
And just maybe we can walk through it because we're not seeing ticks.
We are. There's just not very many. Yeah, here's one.
What is all this?
Here's one. This is when there's only 2 remaining tasks that are in progress. So they do happen. They're just flooded out by this other output. Yeah. So here's another tick. I was doing git grep to try and find println statements.
Yeah.
This looks like one candidate, but unlikely. This looks like another candidate, unlikely. And this is also unlikely. This is also unlikely. So it might be debug.
Oh, maybe we can not do debug.
Function of debugs. Yeah. I forget. I know there's like some environment variable or something in the lab notes about debug. How to run with debug mode enabled.
Yeah.
MapReduce implementation will give you a support for 2 modes of operation, sequential and distributed. In the former, the map and reduce tasks are executed one at a time. First, the first task, blah, blah, blah. This mode, while not very fast, blah, 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 blah. Oh, sorry. Reading the wrong stuff. Okay, debug enabled equals true in common.go. Let's try removing that from common.go. Yep.
Yep.
Oops. Oops. Build. Ugh. And you just said it false again.
Maybe it's in our test.
Oh, that looks like it worked. It removed all that output. So yeah.
Yeah, I think it was in our test, in our map function.
No, Ben, I removed it from common.go. I set debug enabled to false.
Yeah.
And it's no longer outputting.
Yeah, because we weren't printing, we were calling debug.
Ah, okay.
Or, yeah, I mean, maybe we added that, I'm not sure.
Here's all the invokes of debug.
Yeah.
I'm not seeing one where it would be calling just an integer variable. Do you?
I thought it was in test go. But if it stops, it's okay.
Is there some other way to invoke debug? That's super.
No, I think that's right. I think it's map the value, maybe.
Where? Oh, that's what. Oh, this.
Yeah.
Oh, it's printing out the entire contents of the input file.
Yeah.
Got it. So we can change this back to true, as long as in our tests, like you mentioned.
You just comment out those. Yeah, 27, 28. Or yeah, mostly 28.
Yeah. All right, let's give this another try. Yeah, cool. Dude, that is really cool to watch.
Okay, so wait, can we do that again? Because that's pretty awesome.
Yeah, we can monitor the progress as it
that's sweet.
All of the map tasks.
That's awesome, assuming that works.
Yeah, and now our error looks a little different. It looks like the file it's looking for is different. Interesting, right? And here are all these pretty intense.
Okay, so we have input. So it is looking for the. Okay.
Oh, we changed our job name. That's why the file intermediate file is changed.
Yeah. Okay.
Should we change it back? Should we change the job name back?
or maybe we should just make a string like job, MapReduce job, or something. Maybe it should be like phase. The job name should be phase, and then just the task, the next task number, like we're doing there.
Okay.
I don't know. I don't know what job name is supposed to be.
Me neither. It seems like we have to name it something that the reduce phase knows or is aware of. Like we may need to look at the expected reduce file names, because we actually wrote the reduce. Remember?
Yeah.
We had our own convention for naming the intermediate files. We're here in the common reduce file right now.
Yeah.
And we have these file names. There's a function reduce name. And that reduce name gets the file name of the intermediate reduce files.
The job name. So it looks like we're doing it right. What was the error?
The error was that we could not find, or the reduce phase panicked on the file name couldn't be found. Opening this file, there was no such file.
Okay. And then how many do we have that are mrtemp.1? Yeah.
We have a lot. The one we were looking for was mrtemp 1-0-1. So it looks like it starts at 1-1-0. So these two numbers, again, look like we have them backwards for some reason.
Or we're using the wrong, maybe the index. So it looks like we're sending in 0, but maybe we should send in 1. No, or it's expecting, it's either incrementing the index that we're giving it, because I think we're giving it 0, right?
Yeah, I mean, we can add another print statement right here when we're specifying do task args.
Yeah.
We can say task number other phase. Yeah.
Wait, let's scroll up. Task number. So next task equals I.
Mm-hmm.
So shouldn't that be 0? Shouldn't we have one that's 0?
Maybe the job name should be the map file. Is that right?
I don't think it matters. I'm not
Well,
sure.
the job name is affecting the file name here. Oh yeah, I think you're right. It doesn't matter. The file that we are trying to open in the reduce step, which is failing, changed. I agree. I don't think it matters.
Right. But so task number, we're sending in. So it looks like we don't have any task numbers that are 0.
Should we subtract 1?
Well, I don't know.
This one? I don't think that'll solve it. I think we have some really dumb problem with our file name. Like this should be 1-0-1, 1-1-1, 1-10-1, 1-1 sorry, like, you know what I mean?
Yeah.
Like I forget what these two numbers mean. Yeah, this is the lamest problem ever. Let me try running a test again, because now we have the print statement here. The print statement was supposed to be printing about
Okay, so we're getting an error 1-0-1.
Yes.
And can we look at the files that start with mrtemp.1-?
Yes. So this one, I think, is the job name.
Yep.
Given that map task, the job name of 1. So I think this 1 here is, I mean, we can freaking look at the common reduce file, the reduce map, or here's this function reduce name.
Okay.
Forget where it's coming from.
Job name. What does job name say there? Job name is a string. It's the name of the whole MapReduce job.
Okay.
So I think it should just be a string like word count or something.
Oh, we get job name as a freaking argument to schedule, dude. Oh no.
Oh wow. That's funny.
Hey man. Job name.
Yeah.
Son
That looks right now.
Bitch. Let's give this another go. Too many open files. This comes back to the problem that you and I, well, you pointed out at the end of last week's video, which was in our reduce step, we're opening all these files and not releasing them.
Yeah.
We have this for loop in our reduce, and we're opening these files. And then we don't have our defer file.close or whatever. I think we said we'd do it down here, outside of this for loop.
Yeah, I forget why
we closed it, or why we removed the defer.
Yeah.
I don't know. We'll just let's do defer f.close or file.close. I think it's because yeah, we redefined file. We can similarly up here do defer file.close. We have file up here, which is opening the intermediate reduce files.
Yep.
But we never close them.
Okay.
I think we just removed this before. We'll give it a shot. Give it a shot. It needs to be capital C. Oh, it's right here. Okay. All right, dude. We may have solved this. Looking good, bro.
Hey,
you did it. Cool. Let me, before my computer dies a very painful death for some sad reason, which it won't. I just want to get this on GitHub. Cool. Dude.
Okay.
What branch am I on? Answer. We're supposed to be doing this on lab 1 part 3. So I'll fetch and rebates on master to make sure I have master. I'll get diff master. There's a readme. Okay. And I'll unpop the changes that we've done to solve part 3. And what's the command again for running tests?
The test.
Copy paste that and include it in the git commit message. Finish lab 1 part 3. Async tests. And I'll submit a pull request real quick, but otherwise I think we're pretty good. Pete Jacobson. Cool.
Nice.
It's distributing. Cool. All right. 3 down, 1 to go. Part 4, handling worker failures.
I mean, I kind of feel like we may have done that.
Yeah, let's try just running their tests. We may have already done that, yeah. Dude, yeah, this looks pretty good. Like, we just need to add an else statement, you know?
That's looking pretty good.
Yeah. Looks like there might be a fair amount more tests that are of this flaky type.
Yeah.
Okay, too many open files again. There's probably some system level setting I can change to increase the maximum open files, and we can maybe get this to pass. On the other hand, there's probably something we're doing wrong when it comes to opening files.
I think this is, we're doing something wrong with the files that we're opening and closing.
Maybe so we changed that in Reduce, but maybe we just need to change it in Map, because I think we had the same problem in both, that we're not actually closing. We're doing it down here.
Oh, right.
For some reason we commented this out. Fuck it. We should probably do this after the error.
Oh, file.close.
Get rid of all this commenting.
I forget why we did that.
We'll soon find out. We can run the sequential test and see if those still pass. Too many open files. Let's get rid of all this junk. Argument was too long. Wow.
Oh, whoa.
Something's wrong here. Maybe this isn't a runtime error or like a consequence of any single test. It's just that we have accumulated so many files on my hard drive. You know?
That still seems a little wrong.
So added the defer file.close.
Okay. No, so I think we need to do it before the panic.
Okay. Let's give it a shot.
Okay.
We'll run the sequential tests again. Too many open files. Let's revert this change here, right? Wow, how did that fix it?
Well, because now we're explicitly closing it.
You
know what?
Maybe we're inside of a for loop.
Yeah.
And so defer would happen when the function exits.
I think that's what we came up with last time.
We can make a function that we invoke that's a utility for the do map function.
Let's actually, maybe we just need to. Maybe we also need to call it when there's like this error, the other panic error in code. I'm not sure. Oh
no, this is just for removing files, and if they didn't exist, we just want to ignore. Because this is a problem we were having in the part 1 of the lab.
Yeah.
Where we were creating all these intermediate files and we're not cleaning them up before running the tests again.
Okay.
So this is a way of removing those intermediate files for writing new stuff to them. So I think this will panic because we don't have the intermediate files. So uncommenting this line wouldn't help.
Okay.
We haven't really changed much. Like if we look at git diff, the only thing we've done is remove comments. So if we run the failure tests again, oops, go run test failure, we should get this. Whoa. Go what? Go test batch run. So we may get the out of file names error again. Where else might we be opening files and failing to close them?
Too many files open.
This is in, it doesn't, reading
it's in
traces. Common reduce.
Do reduce, yeah.
Here.
I think this is going to be the same thing. I think we need to explicitly call file.close at the end of this.
Okay. Oh, yeah, I think you're totally right.
That is cool seeing like the status of all the jobs.
Yeah. Well, if this test passes, we can take a look at the other two lecture notes, and I am curious about Google File System. Oh, cool. Yeah.
Pass.
Yeah, awesome.
Nice.
Yeah, that was a one-line fix to get the fourth part of the lab working. Explicitly close reduce files. I'll change the pull request name.
That's cool.
Cool. Another one was go test run failure. I'm sure there's a way to speed up that we could be running these tests faster, because that last one took 30 seconds.
Yeah, I wonder if they provide any like benchmarking or something.
For our purposes, we aren't. Two suspicions I've got. One, I'm sure they do. Maybe not as part of the lab. They don't give you guidance, but Go definitely has the tooling for it. But my two suspicions about why this takes so long is we are printing a ton of stuff to standard output.
Yeah, I guess that's true, yeah.
If we remove that, that's actually something really easy to test, is to change debug enabled to false and see how radically that affects the total runtime. We're still printing out a ton.
Yeah. I mean, we could change all of our print lines to debug.
To be debug. Yeah, good idea. It's probably not worth it.
Yeah, maybe that's not even it.
The other suspicion I had about why it's a 30-second runtime to run the failure tests is that we're opening a lot of files.
Yeah.
And reading the contents of files probably more than once.
Yep.
And I think there's some places, yeah, this didn't save any time.
Okay.
I think we can run all the tests for the MapReduce suite by running just go test.
Oh, cool.
So we'll just try running all 4 parts of the lab. We will fail part 5, which was the extra credit one. The inverted index generation, optional for extra credit. For this optional exercise, you'll build MapReduce functions for generating an inverted index. Inverted indices are widely used in computer science and are particularly useful in document searching. Broadly speaking, an inverted index is a map from interesting facts about the underlying data to the original location of that data. Sounds like Google.
Yep.
For example, in the context of search, it might be a map from keywords documents that contain those words. We've created a second binary in main/ii.go that is very similar to the wc.go you built earlier. You should modify mapf and reducef in main/ii.go so that they produce together an inverted index. Running ii.go should output a list of tuples, one per line, in the following format. If it is not clear from the listing above, the format is word, number of documents, documents sorted and separated by commas. Okay, for full credit on this challenge, you must pass bash./test-ii.sh. Okay. Do you want to do that? That sounds not particularly hard. It sounds really similar to the word count one.
Sure.
Looks like all of our tests passed, so we pass lab 1. Congrats, man.
Nice.
We need to go up a directory and go to the main directory. I'll remove all these intermediate files so we can see what all is here. So we have our wc.go, which was part 2 of the lab, and then we have our ii.go, which is the inverted index map and reduce that they want us to define.
Yep.
So the mapping function, blah, blah, blah. I'm guessing it'll return well, it'll take a document or an input file name. Well, in this case, it looks like it takes the raw document as a string and not its contents. Oh, maybe it's identical. It's hard. You see what I'm seeing? Line 19, line 11.
So
the key is in this framework, the key is the name of the file that is being processed, and the value is the file's contents. Okay. The return value should be a slice of key value pairs, each represented by a MapReduce key value. So
I think just like in our word count, we're going to split the words. But instead of word 1, we're going to return word file name.
That makes a lot of sense, yes. So we're going to build up that slice by appending these key values. File name is document. It's really annoying that they don't just call us file name. Like,
yeah.
With H, bro. And then our reduce is going to be similar. Well, the reduce is going to be 2 steps.
So the reduce is going to return.
It's called once for each key generated by map.
Yeah, so we're going to get
a word.
Yeah, so word, let's say it's probably going to be in every one of the documents. So the array that we get here, the values, is going to be the list of documents, which I guess maybe we have to sort or something.
Yeah. So instead of returning just a string.
So yeah, so we're going to need to return a string.
It's just a sorted list. Yeah. Sorting this list of file names.
Yeah.
Is that right?
Yeah, separated by commas.
So using list comprehensions, that would be really easy, but Go does not have list comprehensions for sure.
Well, so Golang had that string.join.
Oh, yeah.
And there might be a slice sort.
So it's a standard library sort package, sort.sort. By age looks like it's a struct.
So
and the important thing about a struct is that it has a property or a interface method called length, swap, and less.
Yeah, is there just...
So we need to define all of those.
Is there just
alphabetical? Yeah. Just do alphabetically. It's a little, I'm sure there will be a string. Was it?
Yeah, there should be like a helper here.
Sort.strings. Bingo.
Oh, yeah.
Sort.strings values.
Okay.
And this will be, we can just return this. We'll need to import string up here, I think.
I think that would work.
Yeah, strings plural.
And then it's capital join.
So the effective Go link that I was mentioning earlier,
yep,
that I read, describes why it's capital J join. Basically, any capital things in the package are available as publicly available.
Oh, okay.
Things. So it's the equivalent of marking something as usable outside of your package. So private public methods are controlled by naming capital letters. Shall we run our test?
Yeah, let's do it.
One fear I have is that I think based on the extra credit, it's mentioning that your value as output for reducer should be the number of documents, space the sorted list. So we might need to do length of values plus space plus.
Yep.
Might need to be the stupid freaking string conv dot I to A or whatever. Surprising how quickly you memorize bullshit like this.
Yep.
Okay. Let's give, what was their instructions about how to run the test? Test-ssh, blah, blah, blah. What directory is that in? Oh, it's probably in main. Oh, it's probably not marked as an executable. Okay. Yeah, looks good. Women, 1, wonderful. 15, 15. Yeah, dude, we did it. That was so easy. We can get out of here. What did we change about common.go? Oh, we changed the debug.
That seems almost too easy.
Yeah. Complete extra credit. So I guess, they don't like bangs and commit messages, because especially with double quotes. If we had single quotes, that's a bash thing for sure. Cool. Nice. So yeah, we did lab 1, did extra credits. You can run all tests by running testmr.sh.
Oh, okay. Nice.
Oh, it's not executable. This might take like about a minute, because of what we were mentioning earlier.
Yeah.
So we don't need to submit it because we don't have an API key to MIT's coursework server, but otherwise we're done with lab 1, dude.
Nice.
I was worried we'd have to spend another week. I wasn't familiar with the other parts of the lab or how hard they'd be, but dude.
Yeah, nice. I think we did good. Although their example of running this is in the seconds, and we are a little bit longer.
We don't care.
It's okay. The class doesn't write performant distributed systems code,
The class is
Yeah.
just
I mean,
distributed systems code.
definitely has to do with I/O. Like all of the latency
Yeah,
here
totally,
is
for
from
sure.
I/O. Like whether to printing to standard out,
Yep.
or writing, opening and closing files.
Yep.
And writing the files. So.
Yep. Cool.
Dude, it's so fucking cold over here. It's like,
yeah, it's cold.
Yeah, part of it is I'm wearing short sleeves and have flip flops on.
That's why I have this sweater on.
Nice.
Um,
To wrap, I mean, do you want to spend any more time? Like, we got the lab notes for the next two. We also have these papers. We could do them out of band off the Hangout.
Yeah, maybe we should do them out of band. We've been going since 9, right?
Yeah, we've been going a while.
Okay.
I'll take this offline. Thanks everybody for joining.
That was cool. That was fun.